AOPS Volume 1, the basics number 14. Show that if A is not equal to C, A to the X is equal to C to the Q, and C to the Y is equal to A to the Z, then X times Y is equal to Q times Z. And like as I've stated before, it is very important in reading such questions to not get intimidated by it, because it hinders your ability to solve questions. When trying to prove some equation is equal to some equation given some other equation, it is important to understand how we can utilize these equations, that a to the x is equal to c to the q, and this equation, to derive x times y is equal to q times z. Try to manipulate it in whatever way you can in order to write it to be x times y is equal to q times z. And right off the bat, we see that a times a to the x power is equal to c to the q power, and a to the z power is equal to c to the y power. We see here that a has bases x and z, and c has exponents q and y. So let us try to somehow utilize this properties that we can find for this relationship. And what we can do is we can raise this equation on both sides by 1 over x power. So a to the x power raised to the 1 over x power should be equal to c to the q power raised to the 1 over x power, which is equal to c to the q over x. And for this one, let us try to isolate a by raising it to the 1 over z power, which is equal to c to the y raised to the 1 over z power, which is equal to c raised to the y over z power. And we see here that both of these equations are equal to a. So that means that this term must be equal to this term. So c raised to the q over x must be equal to c raised to the y over z power. And likewise, from our little trick that we discussed beforehand, if a common base is equal to one another and both are raised to different powers, or so we think are raised to different powers represented by different variables, b must be equal to z in order for this equation to be true. Therefore, with this little tip in mind, q over x must be equal to y over z in order for this equation to make sense. Therefore, we get q over x is equal to y over z. Hence, xy must be equal to qz from cross multiplication, proving this example. But is there another way that we can approach this? Because in this example, we isolated a. Can't we isolate c as well? And the answer to that is yes. We can apply the likewise process to how we did it for isolating a. So if I scroll down to give us some room, we can isolate c instead. So c to the q power will be equal to a to the x power, which will be equal to, if we raise both sides to the 1 over q power to isolate c, a to the x raised to the 1 over q, which is equal to a raised to the x over q power. And likewise, c raised to the y power will be equal to a to the z power. Therefore, c raised to the y power raised to the 1 over y power, while isolate c, will be equal to a raised to the z power raised to the 1 over y power, which is equal to a raised to the z over y power. Notice how both of these terms are equal to c. Therefore, a raised to the z over y must be equal to a raised to the x over q. Obtaining x over q is equal to z over y. Cross multiply to get xy is equal to qz as well. So these are the two approaches that you can use to solve number 14.